Hello. Yeah, so I couldn't leave this monadic parser thing alone. I had to sort of continue on it because I don't know. I just feel like this kind of thing is fun for me, and yeah, just showing you know, the progress along the way. It's fun as well. One second, and I'll get started here. All right. So, yeah. So basically, we have a yeah. So we have a parser in our library here. So here is a parser. I should get rid of this because it's not used really. There we go. Alright, so basically we have our parser, which is a monadic style parser, including things like function closures, like manual hand-rolled function closures, you know, monadic combination of parsers. We have a bunch of stuff. So basically a little bit of debugging utilities. It's not really, you know, it's not very advanced, but I think the thing I want to work on now is basically getting the whole, like we have this small language right now. So we have an AST where the AST, you can build up this you know, abstract syntax tree and create a little program in it, and then you can evaluate it to some sort of number. So basically all expressions right now evaluate into one type, which is the F32 floating point 32-bit number. Or you can format it, which will, you know, format it to some type, to like, you know, some sort of source code. And the way you format it right now, it's gonna be formatted into basically just very simple things. And yeah, it's very, you know, rudimentary right now. So it's basically just you can use it to in main here. You can use it to yeah, here's the example, like source code here, but now we actually read in from a file. But yeah, you can do this. So you can have an out file where we produce the results. So we basically parse this file. Oh yeah, I have a whole bunch of these things, but basically we parse this file, and out comes this file, which yeah, which is produced from this thing. And then we can even run this file as well to get the result out, right? So so that's what we have right now. We can parse this file, we can read it in, parse it, get an AST, produce some Zig source code based on it. So right now it's kind of working like a interpreter / transpiler into Zig. And if we I'm just gonna change this to actually do, let's see, we have standard, and then in main we are going to read. No, let's do it here. So this is gonna be, well, actually we're doing it right here, so let's just grab this. And then we have that. And then over here, instead of doing standard log info, we're going to do try standard out interface write all. Actually, it should be print. Now, I think we also need to flush as well. So I guess we'll do that at the end. I think so. If we run this now, I think it's just gonna, it's not gonna, oh, it did print. Okay. So maybe it flushes at the end. But let's just do it anyway. Anytime we do this, oops. Anytime we do this, we should also print. Is that also a try standard out? Or yeah, flush, default flush, just flush. Yeah, so we need to try flush. There we go. Actually, let me edit this. This is going to execute zig run, no, build run. Sure. And we're also gonna do, so we run it, then we do run out zig as well. Okay, so now let's do that. And we get some error. Oh, I see. These need to be unused argument. Oh, there we go. And we got all the. Oh, I see. Hang on. You need to put into object zig. There we go. There we go. Now we got the result that we want. Okay. So basically, yeah, so now I can run this. I can go here and I can see what the source code will be. I can also like add x minus 10 plus 5.15 and watch how this won't be correct. Oh, it actually... Wait, that's a weird number. Hello, Polar7. How's it going? Welcome. Also, it didn't really update over here. Oh, I see. Sorry. We actually need now, since we're using standard out and not the thing there, we need to do /n there. There we go. Now we get these two. Okay, now it makes sense. Okay. You know what? This is bad. I don't want it to be overseer actually. I want it to be, because it doesn't actually run how I want it to run. So we'll do this. And there we go. Yeah, so if I add this now, it will actually update in the other file there. Okay, cool. So now what I want to do is, first of all, there was an issue last time with actually reading in the file in a streaming manner. Although it's not really a big issue right now. I might want to fix it later, but how it's fixed right now is that we just read in the file as a whole and then feed that into you know, the parser. So basically, yeah, so basically the whole thing is read in, and then we run the parser on it, on the whole string instead, like a fixed buffer stream. And then we, yeah, basically also here, like the limit of one source file is 1 megabyte, but we can fix that later. And we can store this on the heap instead if we want to be even larger later. Okay, so one thing that we could do is try to make NeoVim aware of these diagnostics. And we can also, like, what you could do is you could register this as a new language in NeoVim. So what I will do is check where I have my things. No, not MVM. I think it's like local share NeoVim. Yes. No. Where do I have? Is it config? NeoVim. Here we go. So you could add, for example, you could add syntax. I have a bunch of stuff here already. So for example, we could do this one, mylang. Basically, so I have some things here, but I'm gonna call this one noob. Now I'm using like the old like Vim things here. I'm just gonna copy this. And then we have a bunch of keywords. There's like comments and things. And then we have all these things. We have strings. So this is basically a really like very rudimentary, super simple way of defining syntax. Excuse me. And it's also using like existing concepts that already exist in Vim. So basically I define my syntax matchers here, and then here I will link them to actually to like highlight definitions. So they will, I don't even need to, you know, have, you know, a theme or anything, because it's the concepts of these are stored in this comment, and then whatever theme you're using, the color theme is gonna, you know, define what the actual color is gonna be of these things. So it's a really nice way of doing it. But I know that tree sitter is a way to do it as well, but I think that's a little bit more involved. I haven't figured out how to do that like easily yet. I think this is a very easy way of doing it, and it works really well. So if we just take this template that I have, basically, it's not that big of a thing here. It doesn't have that much stuff in it. And then we can, now what we need to do is we need, whoops, we need to how did we do this? I think we have like files. Isn't there a thing like file types or something? This is just, well, actually, I think maybe, yeah, actually, we're doing this. Yeah. So I'll just copy this. Make a new directory. It's called noob. Put init lua here. And then noob. I'm gonna call it noob lang. This group. And this is noob. Set file type. I'm just gonna see that there's nothing called that already. Oh, there is. What the hell? Wait, did it already work or? Okay, so maybe it already. Wait, what? How can that be? Unless there is something called noob already. I'm gonna double check this. Maybe. No, I don't think so. Okay, so maybe, yeah, it already kind of figured it out, I think, I guess. All right. Okay, so I don't actually need to do this here. So I will, well, you know, what you could do is you could, well, actually, no, because this sets the file type. So, yeah. So that's fine. And here we can also run syntax, yes. And that's noob. But that should work. Well, I guess this is like sets it up even further to work better. Set file. So this sets the file type. This sets this like updates the syntax basically, I guess. Okay, so now we have syntax here. Cool. So now you can see like we have, you know, identifiers basically, and these numbers are highlighted. So you get a little bit of stuff. Okay, so now what we want to do is try to hook up the diagnostics. And what you could do is add you could add like an overseer thing that gets run when you save. And let's see, did I have that for, I think I have it for Zig maybe. Maybe not. All right. But let's see. Let me check how to do this here. So the overseer. And let me show. That. All right. So here's the overseer Neovim here, the repo, which I'm using for. So you can use this. Is basically, yeah, it says the task runner job management plugin. So basically, you can run a command. It will show a nice status for the command, like it's running, it's resulted in an error or success, and then you get the logs on the other side where you see everything. So really nice thing here, and you can like, you know, see all the tasks that you've run and the results and everything. So and then there's a way to set up your own tasks and own things to, and also it can look at the diagnostics, like the results of the logs, and parse them and parse the diagnostics to put diagnostics into Neovim so you can see the results there. Now I might look at this here then. So parsing output parse. Yeah, so here you can see like you can define this parser, and then we have diagnostics, and then there's this way of getting you know, file name, line number, and the message. So this is a really nice way here. Now output parse component, definition of a component parse. You would typically use this in component list of a task that definition returned by template. So I'm not that well versed in these templates and stuff. I would rather just run a command when I save and add this like option to it, maybe. But you know, you can register templates and stuff, run templates. let's see if we can figure this out. Where's the templates, components? Okay, yeah, so these are like different things you can add to your special kind of task. Okay, recipes. No, template definition. Okay, hang on. Custom tasks. There are two ways to define a task for overseer. So we can register a template, directly registering, or as a module. Similar to custom components, templates can be lazy loaded from a module in the overseer template namespace. It is recommended that you namespace your task inside of a folder. Reference as this to load them. Okay, well, let's just stick with the first one. It seems more easy to do. So here's the template definition. Okay, so let's take this, put it in our let's see, our setup function here. So there we go. Now we have that. And let's go back. Okay, so here's the definition. So I guess we will take this and fill in the blanks. I'm trying to figure it out. So we have some tasks. So this would be new blank check. Okay, required fields. So are we leaving out optionals? No, here's optional. Okay, description, compiles and reports errors of, or yeah, compiles the noob.noob file. Yeah, sure. Build, sure. Okay, well, let's look at this builder here. Right, so we have a command. So the command will be, I mean, that would just be like sig build run. And then we have args. No, okay, this is zig, and then we have build, and then run, and then we also, let's also add f reference trace. Now the question, like, how can you can't redirect in here, I guess. So I think we should build into the compiler basically that it should have an in. Maybe like you could add like an in argument and an out argument, but I will name of the task defaults to the command. I mean, this I'll just call this build working directory. It should be the current, so do we have to specify this? Let's try and just remove that. Environment variables, we don't need that. Let's just remove components. Right, so here's, I think, then where we could put components then. But how do we configure them? Metadata. Okay, we'll come back to components. Tags, okay, sure. Params. Not sure what that is. Help overseer params. Schema defined set of options. Okay, I see. Well, we'll leave that for now. Priority. Okay. Condition. File type should be new. Only matches. Okay, well that doesn't matter. Callback. Arbitrary logic for determining if task is available. Okay, I don't think we need that. Alright. So that is all the things. Now the only thing left is like the components. I think we should add the diagnostics one here and try to figure out how we can configure it. So let's see how this works here. What is this? Template provider. So used to generate multiple templates dynamically. Okay, so a way to generate. Okay, actions can be performed on tasks by using run action. Can be performed on task by using run action, key binding, and task list, quick action. Simply a custom function will do something to or with task. Okay, so can you modify tasks or like dispose them and stuff like that? Because that's what you can do if you open a task list. You can do like, you can edit tasks, you can rerun it or like dispose of it. Custom components, that's not what we want, I don't think. Component aliases. Okay, so you could do this as well, but I think this just runs, I think this runs the task, I'm pretty sure. I've tried this before, I think that's the case. String component alias, customizing built-in tasks, right? Parsing output. So here we go. So I think if we add this, you would typically use this in the components list of a task definition returned by template. So let's just copy this. And this would be over here. Components. Now I'm gonna guess that it's just this here. But I guess we will figure out if that's the case. Okay. Lua patterns, right. So the way we report errors is that we have, well, if I run, you can see it works, but if I add like a space here, which we won't allow, you get this error here. So this says, yeah, okay, and then we get the, okay, but this is, that's not part of it. Here we get like error expected at. So actually this is like multi-line. So maybe we should actually start by putting it in the same line. We can determine like how the result will be. Now this only has like the line number, but we also have the column. I'm pretty sure we can put that as well. But let's see, where's the error parsing code? Here is this. Now let's actually, instead of using log error, I'm gonna open what is it? Standard error. So I think we need var standard file system file standard error and writer with an empty buffer, and this is standard error. Okay. Now we will say, well, instead of doing this, we will say try standard error interface print, and we will say noob error. Okay, so we say noob error at, and then we have the file name, the line, and the column. Okay, so actually the file name is this. We had a problem with showing that, but I will try and fix it now because it's, you know, we should have it. So we have line, column, and the message. I will do like comma there, maybe this type of thing. Okay, so now let's go back, let's run this and see if it works. Oh yeah, now we need to, okay, so where we use this here. Hang on. Main. Where we use this, I will do this. Okay. Now we'll go back. Actually, why is this not working? It should only run this if this went okay. Okay, well, whatever. Right, so now we get this noob error at, and then we, oh, now it works. We get the file name, we get a colon, and then the line, comma, column, and then the message. Oh, we need to add, oh, I need to add, now I need to add this end line, new line there. There we go. Okay, but now we get this here. Okay, so let's now parse this line. So I'll put this here as a reference. And first we have new error at, and then here is that, and then we have a colon with this, and then I guess we can do this as well to get the next number, and then that's the thing. And then not sure what this is called, but I will look it up. Hopefully it will say somewhere. Quick fix item format, help set queue. Okay. Oops. Call, just call, okay. What's the issue here? What's happening? I think there's something weird with Lua. Yeah, the language server is weird. Okay. Okay. Now that is good. Okay. So will this work now? Let me try and restart. And we'll open up this guy. No. Okay, there's something going on with something somewhere. Oh, I'm not calling this function. That is why it doesn't work. So basically, I have like an init system here. I will call a bunch of init functions. Now, where is my line? Not here. Oh, this is just... Oh, here we go. Okay. So I'm not sure, like it seems to work anyway, but it just doesn't know that this is supposed to be this file type. Yeah, because there's no file type like that. So, okay, now if we restart, okay, so I think the syntax work. It's just run. No. Where did I have the thing? Because it doesn't run this automatically, I don't think. I have to no, init vim. Or does it? I don't think I don't think it just runs everything. It should run this, and this one just runs everything like in it all. Maybe I disabled it. Yeah, that could be it. I probably disabled it. Okay, so let's just add this here. there we go. Now it's the syntax is automatically loaded now. Or the file type is automatically set, or was it before actually? Okay, now I'm. Let's just do this to check. Let's just log. How did you do this? Print? No. Vim. Message. No, how did you do this? Create, no. Oh, echo, that's not echo. Wait, how did you... No. Man, there's so many things. There we go, echo. Once you've been out of it for a while, you forget everything basically, because it doesn't function as other normal things. Okay, so echo will say something here, noob in it, and that should show up somewhere. There we go. Now we get it's okay. Now we know it's running. Okay. Undefined variable noob, but oh, I thought it would be. I thought it just. Oh, result of expression. Okay, well we know it's running, so so good. Let's restart. And then we go in here. And so now if we go back. Okay. So we have our template. Now we need to figure out, okay, how do we run this now? So let's go back to the browser. And okay, so we can run a template. So this, presumably we could do this in a you know, writing pre-write or post-write or something. We'll see here. There can be two ways to get tasks to run sequentially. First is use dependency component. If you want to use to run, oh, I see. Oh, so you can do that if you want. Well, I think I just want to... I just want to run... I just want to run the thing. Restart, close task, no. Custom task. How do I just... No, wait. Run it. Oh. I like it when they show like alternatives. Tutorials. There's like, okay, there's guides, explanation, recipes, tutorials. There's like a million things. Okay, and it all seems to be Okay, run a file and save. So we have some templates. Okay, that's a very simple template definition. It's a built-in user run script. Okay. And oh, I see. It's like a template definition in here. And it does some stuff on output quick fix, on result diagnostics. Well, we'll see what we need here. So how does this get run? Is the question. Open up a shell script and run. Oh, it just, okay. Okay, well, let's try that actually right now. So it should be here. Overseer run. There we go. Now we can check. Build did not finalize. Missing on exit status. Oh, so I need to add a bunch of components, I guess. Maybe. Okay, let's see how that works. So components on exit set status. I wish there was a better, like, it showed the whole thing, like when you define the components. Also, it's a list of things, so this needs to be in its own. Oh, I see. So if you have like arguments, you will do this, and then okay, so then and then let's add default also at the end there. So this needs to be in its own thing here. Wait. Oh, it added that one automatically. It add that one and then add default. And then I guess we have this one as well. Okay, let's try that. Oops. Overseer run. Hey! It works, and we get like we have it in our error. So now it's in the diagnostic system of NeoVim, so our own like language here. So now we need to also make it so it runs on save. Oops. New. All right. And this I'm not really sure, like how to launch Overseer. So this would be like create group, new blank build, or yeah, build, whatever. Can you have spaces in these? Whatever, let's do this. Clear. Wait. String and then options, right? Yeah. So I think we have like callback. Oh no, I zipped it. This is the group. Group. Actually, whatever. Let's just use group. Okay, yeah. This is buff, right, and I guess post. Or is it? Yeah. Let's try this. Let's see how it works. Okay, so what's gonna happen here is we are gonna do. Yeah, this is where the thing is. what we do here. So I guess we have run template, and yeah, we don't get any help here basically. So this registers a template. So I guess we can put the name in. Okay. Help run temp. No. Overseer temp. API. Run template. Run a task from a template. Name. Okay. Let's do name. Auto start. Start the task after creating it. Okay. Default is true. I see. You don't have to start it. I see. First, went through, take the first result and never show the task picker. Default behavior when auto set is based on presence of name task. Okay, first is true. We only have one thing. Prompt controls when to prompt the use of a parameter input. Never. Parameters, we don't have that. We don't have current working directory. We don't have, right. And you can also have a callback, but I don't think we need one. And okay, cool. So now if we go out and we go back, oh, valid key pattern. Oh no, this is auto command. Sorry, auto command. There we go. Yes. All right, so we save, and nothing happens. Okay. Great. Why? I'm pretty sure this is run. This is ran. Run templates. Let's see if we messed something up here. I mean, it's auto starting. It should auto start. We should pick the first one that we have. Name of the template to run. I mean, we have. It's kind of hard to see here, but yeah, the name was taken from the template. Is it this that we need to grab? I mean, this is the name of the task, but there's only one task. Callback. Prompt option when control will use a presented pop-up. Never show prompt. Okay. Run the task, make all. Run the default build task. Oh, I see. You can do this. Okay, that's pretty clever. So you don't even need to know the name. You can just say, okay, well, is this the build task? Then run it. With some parameters, create a task but do not start it, or start false. I see, and then you can have a callback where you get the task and then do something else. Okay, let's do this. Let's see if we just get in here. So let's do echo hello. No. I'm pretty sure. Yeah, the pattern. Maybe the pattern is wrong. Maybe we need to. Maybe it needs to be like this. But that doesn't make sense. Why are these different then? Maybe they never worked. Okay, there we go. Now it works. Cool. Let's remove that. Okay, there we go. Now we get like... Okay, well it didn't... it doesn't clear the diagnostics. Maybe there's like a component for that. Set diagnostic, add matching... Okay, on result diagnostics, remove on restart, that should be true. Yes, so let's set that. Where is that? Okay, so we have to do this and then have... Okay, so the first one is the name and then we can have the... So what is it? The name? Components. And diagnostics. What is this? On output quick fix. No, we don't want that. This one. Remove on restart it was called, so remove on restart is true. Okay, now let's see, we add this, there's an error, it didn't remove it though. Okay, maybe it's because it doesn't restart. Okay, let's see if we can figure it out. So not remove on restart. What if we remove this altogether? Yeah, it does show. Yeah, remove and restart true. Actually, API run template. Can we make it run the same task? This seems to be like, this should be like a very common pattern. Like you want to run when you save, and you don't want it to, you want it to be the same. Do you return something? No. What about new task? Creates a new task. So you can do this also. To just define this task, and it's gonna run, I guess. But the problem is I want it to rerun. Oh, there we go. Start. It gives us a task. So what if we say like overseer run, no, new task. You will give us, it doesn't say. Okay, I'm just gonna try to Google real quick here. Overseer rerun same task. Or overseer clear diagnostics of previous task. No. See, if you look at, okay, here it's definitely, like it just says on result diagnosis, not even clear on restart. And diagnosis is true. So this would just show it. But, and this is a template, I'm pretty sure. Yeah. So how is that working? Like how? You should see inline diagnostics. Okay. Quick fix. But I don't want quick fix. But here it doesn't show quick fix here. Output should be updated. You should inline diagnostic for an error. We'd like to restart it every time. Save the file. Once more, use it over quick action. This time, select watch. What? Okay, hang on. Run template. And we get a task. Restart on save. Oh. Okay, well, we don't need to do this. So we could do this. Add command. Okay, restart on save. Oh, why don't we just do that? Okay. Then we don't even need this. I guess we could change this into like, I think it's like buff enter. We run this. We have a callback with the task, and we say add component. We start on save, I think it was called. Okay, they actually do it like this. What? Oh. P. What is P? Is that just like absolute path? Okay. Yes, okay. Let's see. So restart and save. So this should make it so that we start on save. I'm just gonna make sure run template, the callback. So this one, run task and immediately open the float window. So this does it after, but I guess we can actually modify it, I guess, afterwards. Open float. Oh. Okay, so there's a whole bunch of things you can do, but this, okay, so we need to check this also. All right, so let's try that. Now hopefully this won't run every time. So the problem here though is that if we go out back and forth, it's gonna start several of these, I think. But let's just see if this works first of all. Oh, did I remove? I removed the component, I think. No? But now it doesn't say. Oh, there we go. Yeah, see? Now it's probably get like a whole bunch of these. So if I save, nothing happens. Okay. Okay, so why is that not working? Restart and save. So is that not the components? Restart. Interrupt running tasks. Mode. Auto CMD. Default. So what is default? Okay, whatever. Paths only. I mean, okay, so it should work. The only problem here though is that maybe this. Maybe we should just run it first. Like we start it. And then there's like condition find not loop. Only matches current buffer. So does this mean that the okay, this means that the template is like registered at this point. And we can't really run it here if we haven't opened the thing. Maybe this should be like a once. I want this to be like a once per buffer though. Can you have that? I know that you can have once. But that's just once for all of the things. And maybe that's enough actually. Yeah, because it's probably gonna run on the current file anyway. Yeah, we're running this command here. So we don't even have... Okay, so then it doesn't really matter that much. Okay, so we'll do this once. There we go. And then, but the restore on save didn't work. So let's say, what was the thing? Overseer API, run template, callback. Oh, that's the second parameter. So this is, okay, so I did the wrong, this should be like this. Two arguments. Oh, sorry, this is, okay, hang on, 1 second, sure, sorry. Here we go. Okay. Wait, what? Okay. And then... Okay, well, let's just see if it works now. Oh... Wow, okay. Finally. It works. We got our little language, and now we have the diagnostics being sent directly here. So we have... I mean, the only thing missing now would be to have like tool support. Would be like an LSP. But yeah, I have done LSP before, but it's just so much stuff you have to do to get it up and running. But I mean, it is possible. Okay, well, this should be good enough. Yeah, I just wanted to like improve on it a little bit, and now we can build on the thing. So. I mean, I guess, the thing is that I don't even, you know, I don't have a good idea of what to actually do with this now. I mean, we could expand on the language, we can add more features, like build out the AST, you know, things like that. You could add like types and, you know, maybe, you know, have the concept of constants versus variables and stuff like that. Complicate it even more. Functions, conditionals, loops. Yeah, there's like, you can do a whole bunch of stuff. But I think the idea that I want to, yeah, I just wanted to show what's like with relatively little also you can do to actually get this get like your own language basically working with this kind of tooling. Questioning your understanding of time. This stream should not be at this time. Now, I felt like having a bonus stream today where I would work on the parser a little bit, or this weird language a little bit. Yeah, okay, so now the problem is, I mean, this is kind of weird. Expected, I mean, okay, the error messages aren't the best, but the point is that we actually have them in the editor. Okay, so what do we do now? So yeah, that is the question. What to do with this? I guess we'll just implement more stuff to make the parser better. Probably. So what would we like to have? All right. Yeah. Thank you. You too. See ya. Let's add something here. I mean, okay, let's just add like more math functions, maths functions. AST. Okay, so we always start at the AST. I mean, yeah, because that's like the end result. Or not end result, but that's like where you have the stuff. Anyway, so we have add, subtract. So these are like binary operations. And so basically we could have one that only is like binary operations. That will be these things. So I think what we'll do is we will say we have our binary operation, and so we have like left and right, and then you have an operation which then is like a binary operation. So that could just be an enum where we have like add, subtract, multiply, divide, and so on. Now, okay, so this is like more generic now, and now we can add these things in here. And now, basically here, I wonder how this works. Like if you say left equals this, and then right equals this, will it actually evaluate right at this point? Or will it wait until it's absolutely necessary? Like lazy evaluation, like left plus right. Like, because we know that this is kind of substituted here. I'm not sure how the sig works, right, like this. But really what we want to do is we want to switch on the operation, and if it's add, we will return left plus right. Subtraction. So at this point, like all of these are going to be evaluated anyway, so it doesn't really matter. And divide. Now divide in Zig is kind of weird, so I mean these are all F32s, so that should be fine. Alright, so basically this is how we can sort of generalize. Now we have to put all the implementations in here. However, this could also itself be a union enum and then have all these. So there's like different ways to approach this here, actually, and this could really be, or you can make this into a generic. You could make it take an operation as a like a, or one of these as like a type parameter. Yeah, there's just so many ways to do it here, but let's just do it like this for now. And so we'll have this switch here, and basically we wanna do this, except we do like this. Oops, where did I go? Yeah, so here, yeah, that should be fine. And we could do the same thing here, like left equals south, left, right, oops, and then here we can do this. Have it a little bit easier. I guess this could be a constant as well. Whatever. Alright, so now we have our little binary operation instead. So now we can switch to use this instead of add and the other stuff. So we'll remove this and we'll have binary. And now we should get a whole bunch of errors. Yeah, and we need to go to, I think, the parser to fix this. Wait. So add expression. Let's do, oh, I see, we have to add expression, right. Yeah, okay, so we already have kind of made this thing here, and this now does not work, but what we could do here instead is to add and sub, which will be our binary operation. And then we basically just return operation is binary operation, and this is actually not T now, this is AST binary. And yeah, now, okay, so this should still work now. Okay, I didn't see, it didn't show up here, but we did see it. Okay, it actually works as I want it to work, actually, because I don't want to see the errors until until I say so. Okay, now so we got these things. Okay, so we can add more of these. So to multiply expression, division expression. Okay, and now these ones are also pretty, you know, similar, but yeah, whatever. Let's just add multiple expression. Let's call this multiply just to make it super clear. And that is to multiple expression. And division expression. Okay. Actually, one thing that we could do is remove all the like white space and have proper white space parsing. Right, multiply expression and division expression. Here we go. Okay, so now we should be able to handle those. So let's go in here and let's say we do times 2. And we don't get any errors. If we run this one, we get -5. This is also interesting. There's no the ordering of these binary operations is not, you know, following traditional mathematical rules. So basically, if we put also there's no like parentheses or anything, but if we put as you can see here, this is -5, which is wrong. I mean, x is 15, x minus 10. Actually, no, this is correct. Okay, so x minus 20 is -5. Okay, that's correct. But if we did this instead, what would we expect this to be? We would expect this to be 150 minus 2, so 148, right? But it is 148. Okay. Sure. Okay, maybe it didn't matter in this case which was which. But okay. Whoops. No. What's happening? Okay, so this is more ambiguous. I would evaluate it from left to right. Maybe 150. Yeah, 75. Okay. Now this should be like 19. No, 29. 29. Yeah. Okay. Well, anyway. Whatever. Okay, what if we did that? Okay, now this is 29 and then times 3. Okay. Will it say now 90, whatever, 87, or will it say, you know, 26 or 27? What? Oh yeah, because it was from 30 to... Okay, I don't understand how this happens, but I guess it already works for some reason. Oh, you know what? You know what? Why it works? Because I'm not actually evaluating the order here. Zig is evaluating the order, because this is actually turned into Zig. Yeah, this is turned into Zig and then printed out. So actually, that's why it works. Okay, I was like, what the hell? I didn't implement this, but Zig actually takes care of that. Okay. Right. Well, what if we made some actual things with this? I was thinking because we have like the state machine in Zig, and in the game code, and we could try to make it so that we can like generate. Okay, actually no. One thing that I would like to do is parse the game editor files for animations and entity types and all that, and then generate the types that are. So there's an actual use case for this in my project that I have. So I can build parsers for that, and then use that to generate Zig code based on those JSON files. And I mean, I could also just use JSON, the JSON formatting library, to import the JSON files into Zig, a Zig program, and then generate code from those directly. I don't really need a parser to do that, actually. But hey, it was fun building it anyway. But we could make our own little like definition language for example, the state machine system, or perhaps entity, like monsters. I don't know. We'll see. But what do we want to do? Let's add, let's do the white space thing, because that should be possible. So let's go over here and we will do something here. I think I want to generalize this into binary expression. Make binary expression. So we would like to have, so we're gonna have a binary operation. We'll get a parser function out. And this is gonna be returned. And we can also get the breadcrumb. Okay, so this is the breadcrumb, and then we basically, we need the builder as well. Oh yeah, actually the parser operation. So the binary operation. So we could define the binary operator. We could actually do like two, like we could do the character, or I mean the the string actually. And then we just return switch ourself. And we have add and so on. Okay, so now actually here, well not here, but here, we can actually just, we can just do this, return s f. Let's just do this, so self operation string, and then right. So we don't even need this. Actually, you know what? Let's just make this as a let's just do this as a format function actually. Yeah, let's just do a format function. But this would be like try write on. No, but this needs to be a string. And do that. Alright. Okay. So now we can reuse that here. And since it's comp time, we can just add it here. I mean, this is gonna be, I'm gonna switch this out here, but basically, oh, this needs to be format, right? We could make a parser that takes a writer. No. That would be silly. Let's just make this string here. So operation string buffer. We don't need many things there. And then string is going to be standard format. Buff print. Actually, this is format. There we go. So now we have that. Now this one we can actually catch unreachable because the only thing it can happen is that it doesn't fit, which it has to fit there. And then this one. Actually, we could use comp time print for this because we have. This is a comp time. Yeah, we can use comp time print. And then we can just do this as well. There we go. Oh shit, we need these. Man. Okay, let's do this. Let's make a struct called expression parsers. We'll do like singular multi and any and we'll pass that in here. That needs to be a pointer, but we're not gonna change it, so it can be const. Actually, these can be pointers, actually. No. Okay, so now we do expression parsers singular. Actually, let's just call this. It's fine. Any. All right. Now we wanna make expression parsers and maybe they should be pointers actually. Well, no. Actually, we'll do this. These guys are gonna be up here. And then this will be here. This is any, singular, multi. Oops, lazy. All right. Okay. And that's const, so that's fine. Now this needs to now switch into make binary expression. Breadcrumb is add. Actually, we don't need expression. Let's just remove that part. Add, and then this is add. I mean, we could even do plus. Yeah, we can even actually, you know what, let's just do this. No, runtime print. Yeah, there we go. Now we don't need that. And the expression parsers. There we are. Okay, now we just, oops. Do all this. Multiply. It's almost easier to just, yeah, let's just remove this whole, and do this. Oh. Here we go. Right, so this will be expression parser stuff multi. Singular. What is this? Oh yeah, this is expression parsers any. Actually, you know what? Let's back that up, and I will just set this here. So expression is parsers any multi. There we go. Okay. Are we back to square one? 22, 21. What? No. Okay, I might have messed something up here. Add, sub, multiply, divide. Add, sub, multiply, divide. Add, sub, Oh, everything is add. Okay, that makes sense. So now this would be two binary expression basically. I need to do like two binary expression that takes a comp-time binary operation, and we will return a function that takes this godforsaken struct here, binary raw struct, which will be first st expression and then a string expression. Yeah, I think that's it actually. So you take a binary raw and you produce an AST binary operation. All right. So let's return this struct. And this takes raw, returns the binary, and that's the thing. So we just return left is raw 0. Operation is binary operation, right is raw 2. Okay, there's our mapper function. Now we set that here to binary expression, and we need to call this with binary operation. There we go. Okay. A little bit of currying going on here in our Zig program. I love it. It took a while for me to actually try out some functional patterns, but yeah. It works. I mean, it is a bit clunky sometimes, but I feel like it works pretty well actually. Better than I thought it would be. Okay. Now. Yeah. Okay. So now let's try this again. Okay. There's no errors. Let's see what it does. Okay. Now it works. 15. No. Yeah. 15 plus 5 is 20. Minus 2 is 18. Yeah, and we can look at the result program to see that it actually works. Great. Cool. All right, so now let's do the white space thing. So let's go to parser, and we have our binary, you know, the binary parsing here. So instead of doing this, I think what I want to do is I want to make a version of sequence that ignores like white space between each thing, right? So we'll make a version of this, and And I think if I go to parse string, we can take inspiration here. So I will copy you and say parse, and then do sequence skip. So sequence S will be a skip white space basically. Okay. Now, yeah, we don't take a list of, we don't take a string. What we do is we take the parsers and we return, yeah, I think we just want to map those away, like the white space, we don't want to include them in the result either. Probably, so we could build a mapper that will okay, my mind went somewhere else. I thought I was thinking about the closures for a second there. I think I found maybe another way to actually create the closures, but I'll test that some other time. Anyway, this, so if we look at the sequence type, we have a sequence tuple helper function here that we can use, and that will be the results here. And then to be able to do that, so we are creating a tuple of parsers with length. However, we also need to add more things. We need to add, oops, one, no wait, we need to add hang on. We can't just add one there because that will length. So if we have 4, right, we need to add 3. So, but this one starts with 1 times the length. So but we could just do this, right? Because we're working with 1 times something, and this should be the sum here. Yes. So it's going to be the length plus length minus 1, because it's interspersed. So if we only have 1 item, we shouldn't add any more. If we have 2 items, we should add 1 in between. Right. That's the idea. And then we have our fields. Also, this parser function is wrong. So that is actually interesting, because this type is unknown, really. It's like an any type. Actually, this should be like, this is kind of weird. This is also a tuple, actually. Yeah, this is kind of weird. This is an array of types. Well, I guess the types can be different. So I guess we will build this type array up. Actually, so this will be an array of types. Okay, and then we do an inline for parse. Well, actually, this would be like 4 fields of will add, yeah, actually, yeah, there's a maybe index here. So we will add we'll append, actually, we will append this list, which is gonna be parsers. This is gonna be field. No, this is just gonna be field type. Yeah. Yeah. So we'll add this type in. Then we will, yeah, we don't even have S down there, so whatever. Okay, then we'll check, okay, are we at the end? If I is not equal to the field's length, so if I is not equal to length -1, that means we're not at the end yet. That means we need to add another type, which is going to be, I think we need to make a slice as well. Then this is going to be the skip white space part. So this is going to be like a parser function, I don't know, a string to get the white space, you know, extracting the white space. Probably, I don't know, I haven't written the function yet. Skip white space. This would be like take while, take while, and then condition on parse char. So we'll basically just, no, this would be like take one white space. And then the condition will be oops. The condition will be, actually, you know what? We probably have this here. Is white space. Okay, and this is like, oh, I see. Okay, so I guess this is like everything. Okay, cool. Hopefully, not sure which comes first, like /n/r, I don't know. Anyway, hopefully, yeah, that should be correct. Okay, anyway, so now we should have our thing there. Also, actually, yes, this will return a list of bytes, so that should be correct. Okay. All right, so now we should have our list of types. So this is now interspersed with the parser functions there, and then, which is probably a pattern we could repeat, like with commas and semicolons. Yeah, there's a lot of maybe those, but anyway. So now we make our new tuple here, and we can add these types in there. So now we have our tuple type with the interspersed things there. Yes. This is all to be able to make this type here. To be able to create a new tuple that have interspersed parsers in it. And so we have this here. And now we inline this again. And we get a parser, no, a field. And tuple, so we say field of tuple. Oh shit, no, this actually needs to be, you know what? This is kind of weird. See, yeah. Like I know there's a way to turn a number into, you know, the field accessor that we need for a tuple. Man, I wish, actually, you know what? This could be solved easily if we just had a producer, like an iterator producer of parsers. Parser iterator. And we have a parser that accepts an iterator. Parse iterator. Yeah, and then this would be a parser function. Okay, this is where it becomes weird. What would the type be? Is this a tuple? I guess we're back to the same problem. Or we could just say it's void and skip it. Because there's no way, like if it's an iterator, yeah. We could get the things. Can that actually be done? How would we even do this? That would be like having, yeah, we would need to have a list of, okay, let's just try to see if we even can define this function here. I'm just gonna say that this is void, just to make it easier. So we need some sort of next function. That returns a parser function. Let's just do void for everything, or null. Now the problem is, where is the source of this? That's the issue. I mean, I guess we could I guess this would be like interspersed with interspersed iterator. And we would have like intersperse C? No. I don't know. Whatever. Yeah, let's just do like the space parser, which is a parser function void, and then we will, I guess we have to make this into a function, haven't we? Parsers anytype type. Actually, this should be like a comp time. Because I don't think you can pass parsers as a value and then get a type out. You have to have a function that takes the type and then creates a type that we then return. Yeah, and now we actually can say, no, we can't, because this returns each one individually. And the parsers is the parsers. Space parser. Oh yeah, we also need the space parser. But is this even a good pattern for this? I don't know. Okay, so basically, and then we also need like the index. Okay. So here we would say if the index modulo 2 is 0, so each time we have an even number, we want to just, actually first let's check for the termination. So index must be less, index must be not equal to fields of parsers dot length. If it is, then we say -1. If it's actually, if it's equal, yeah, if it's equal to this, we will return null. Okay, let's just do more than equal just to have the safety there. And then modulo 2 equals 0. That means we should return the parsers. Well, first of all, that means we can actually divide exact by 2. And so we can also, but now we can return parsers div exact index by 2. Okay, that's the parser. Otherwise, we will return the space parser. Okay. Now that's an interspersed iterator. It would produce parsers. Every other parser is going to be a space parser. Now we could also make a void wrapper which will always return a void parser, and we will say constant void, actually parser. Okay, so now we can say that, well, the thing is, this doesn't really have to be void. We can actually take an any type here and then say that this, and we need the builder. We could actually move this function out. Interspersed iterator, self parser builder, parsers. Actually, parsers can be any type as well, so super easy to define them. We will return a parser, no, interspersed iterator, and this is going to be type of parsers. Yeah, and then we do yeah, and then this one is gonna be actually, now we can even say like that the space parser can have a type as well. We don't actually, well, this is still, you know, this still needs to be void since we don't know the type. But now we can have an init again that returns this, and we need parsers and space parser. And we'll also get the builder. Turn. So parsers is parsers. Space parser is make void space parser. So we don't have to do that every time. And actually now this one is void actually. And here, actually we can store the builder as well, because then we can use make void here to actually map that into a void to get the correct return type here. Okay. And then here we're going to do type of space parser. It doesn't, I guess we don't really need that. We could make them void before, but this is just to make it easier to pass in any type of parsers here, instead of having to make them be void before. And I'm just gonna comment this out for now. Now this needs to be self-index. And oh yeah, so now we need to use init. There we go. Okay, I think, yeah, we have a iterator now, although the type here is kind of weird. I think, yeah, I think this needs to be any type then. And then, yeah. And is this gonna be a new primitive is the question. We don't really have a fold. But this would be, would fold even work here? This is kind of like mutating, you know, having a side effect. Yeah, let's just do a new primitive too, and then maybe we can fix it later. It's gonna be kind of like a sequence, I guess. And this will work on any iterator, but also the iterators has to be void. That's the problem also. Yeah, it doesn't fit very well into the format. I just want to see if I can make it work. So let's copy this. Okay, we don't have a type. It's gonna be a void. We do want to store the closure, but this, we actually, it's already a pointer, so we can just store it there. This would be iterator. And this is going to be void. Okay. Yeah, so we are gonna get closure iterator here, which is gonna be type of iterator, except it's, yeah, that's just, actually, couldn't we just do this, body cost, yeah. So we have the iterator now. And instead of doing this crap, we are going to do while closure next. We get the next parser out. And now we run this parser. Switch on the results. If there was an error, we will get the error report wait. No. this is what we'll do. I think there's something wrong with the syntax somewhere. That's why it's acting weird. Okay, anyway. Or if it's a success, we will just continue. All right. I think that should work. I'm not sure how much this, how use this is gonna have, but I guess it works for this if we. Let's actually. The thing about the sequence is that we could potentially get the type out, like the information out from the sequence. And that's, we actually need to get the type out. So so we can't even use the iterator. But let's keep it around. Anyway, I think it works, but I won't use it right now because it produces a void. So the only way it's gonna be used is if we want to intersperse something to some iterator tuple and then don't care about the result, basically. So yeah, but let's bring this back now and try to do it actually for real, which involves this weird kind of like where first all this is just building up a type that is going to be the resulting type. Then we need to populate a tuple of that type to the correct thing. And I don't remember where I saw, you know, I think we have like tags. No, where did I see that? It's like buff print. Yeah, here it is. Create unique to. So it's like when you create the tuple, you can, for the name, you can use this. So it's the actual 0. No, it's not 0. It's the string, just the string 0. Okay. I mean that works. So what I want to do is I want to have one index that is gonna be for the parsers, and then the other index is gonna be for the interspersed one. So first we'll populate. Okay, so we'll do basically the same thing as we do up here. First we populate the tuple with the field name. Actually, no, we can't. We have to do like field name is gonna be this. I'll just make this real quick here. There we go. A buffer there. Okay. So that's the field name, but it's going to be I times 2. and then that's gonna be equal to parser's field name. Now we can use field name because that's the first, because we're looping through parsers, so we can use that to access the nth thing in parsers. But the tuple needs to be that the tuple actually needs to be interspersed, so the field name here is going to be I times 2. And then if we're not at the end, we also want to add the intersperse thing. So we want to say I times 2 plus 1. So let's call that J, I guess, to make it more maybe simple. J plus 1 J. Yeah. And then yeah, if we're not at the end, we will have another field name. So this is interspersed field name, and then field of tuple with interspersed field name is going to be equal to whatever space parser we have, and that's going to be like skip white space. And now, I mean, yeah, actually we could have an intersperse function, like an intersperse parser, which probably should have anyway. Let's let's make that one instead, and then sequence S will use intersperse to make the thing, right? So this will be intersperse. However, this would actually be an intersperse tuple. Yes. And then we get type of parsers, and then also type of space parser. I'll call it space parser. Why not? And that's also an anytype. Okay, and now we need intersperse tuple that takes parsers and space parser and returns a type. Okay, we'll figure this out here. Can you have an empty tuple? Apparently. Okay, I'll figure it out here soon. So, but now we have that. We have the, this is going to be the result, yes. Now this one is actually going to be the type of space parser, right? Yes, we're building the type up. So now we actually include the interspersed as, you know, additional data that you can extract. Okay, so we'll add. So now we're building the tuple actual value here, and now this one is actually going to be the space parser instead. Okay, so now we made it generic, and this is going to be intersperse. Actually, let's do. No, we don't. We actually never set the breadcrumb here. No, we just set the label. Print. intersperse this with this, and this is going to be type name. Actually, this, it's like a tuple, so we don't, do we really want to show that entire thing? I don't think so. I'm just gonna say the space parser. There we go. I mean, we could get the type of the whole thing, but nah. Okay, so we're interspersing there. Okay, well, now we have the label, okay. And this, what the hell is this? Oh, I see, we don't need to do all this crap. We'll put this here. Okay, there we go. So we just showed us the space parser there. Okay, so this should be the same thing, except this mapper is weird. We don't need to map anything actually. We just want to run the tuple actually. So basically, yeah, this is just running a sequence, except we get a tuple in, and then we intersperse with this thing. So actually, we could probably just make a function that intersperses a tuple and preserves the types, and then use that generic function into a sequence. But anyway, actually, I wonder if that exists. I mean, probably not something that could preserve types. Okay, anyway. But now, yeah, now we're building the type. We're interspersing with this space parser type. We are creating. This isn't used. No. Let's remove that. Oh, this is sequence S. So yeah, so sequence S needs to be fixed. This one we can remove. Yeah, we're building the type. We're creating a value of the type. We're filling up the type here with our parsers and interspersing with a space parser. And then we're returning just a sequence with this new tuple. And we're setting the label. So that should be good. Now this one, actually, because we want a sequence tuple, we don't want to actually, we don't care about the white space. So we want to just discard those. So what we do is we return intersperse parsers with skip white space. Okay. Now what we want to do is we want to map this now, because this includes the white space in the result. So we want to map that out. And that's going to be interesting. Oops. Okay. Let's just create this here. So we have a mapper. We take the input is going to be the intersperse tuple of these things. Oops. That's the input. Is there really that many parentheses? Okay. And then the output is going to be the sequence tuple of parsers. Right, so we're basically undoing the interspersions, except now we're working with the actual value, not the parsers. So yeah, well, this is going to be pretty easy since we already have the types. So actually this is just a sequence tuple type of parsers, right? And we set it to undefined, and now the only thing we need to do is fill it up. So let's loop through. I mean, we could just loop through it as well. Okay, this warrants a T here actually. There we go. Now we have the resultant type. Okay. And okay. So we loop through all the fields. We get a field out, and we should set the field of results to. So now we need to get the field name of the interspersed. So we'll do this, and this will be. So we need the index. Now this is going to be like index times 2, I'm pretty sure. Because the interspersion, yeah, the interspersed one, which is the input, is going to have like every other element that we need. Okay, so now we're filling up the result using only every other value in this tuple, and now we return this result here. All right. Oh yeah, we need a buffer. Okay, there we go. Okay, so the only thing now is to define this type. So let's go over here, and I will copy this, and yeah, so basically with same logic here, we need the index. We're gonna check if I is not equal to length minus 1. So if we're not at the end, what we're gonna do is we are going to add yeah, space, like get element of space parser. How come I can't do this? I should probably do this. That's more correct, I would say. Okay, so if we're not at the end, we will also add the type of the space parser interspersed in this list. Unreachable code. Excuse me. Oh, because we're returning this thing here. Okay, there we go. All right. Now we have a way of interspersing a tuple of parsers with a space parser. We also now use this here. Let's actually, I think this mapper should really be like remove interspersed. Like remove interspersed. But this is more like a mapper function. Map. I mean, usually the functions in these operate on the parser functions. So if you remove intersperse, you probably just map on it. Yeah, I mean, let's just do that, I guess. But you don't want to remove. Okay, remove. Okay, I guess strip intersperse from result, I guess we can say. That really hammers home what we're trying to do, I think. Parser builder. Sometimes you just feel like, okay. So actually, this is a sequence tuple now. No, this is an interspersed tuple. But we don't actually have a reverse of this. We need a reverse of this. You know what? I'm gonna leave it actually. Because in this function we actually know the type that we want from the start. But if we were to make a generic function that takes an interspersed tuple and then and then returns a sequence tuple of the inner part, then we don't really. Yeah, we have to make like a reverse intersperse type function. So I want, no. It's too much, I'll stop it there. But now we actually have a sequence S, so it's the same as sequence, but the only difference is we skip white space in between. But there has to be white space in between. Actually, you know what? There has to be white space in between. Yeah, that's the thing. So actually skip white space. And I think I want to add some n here, which is like take at least n. So we want to take at least n. Skip white space. So that's what we want to do. All right. I guess we could make a. I guess we could make a version of intersperse that discards the values of the interspersion, so we don't actually. So it actually maps the thing. Do we want to add that as a separate function though. Okay, let's do that. I'll add like an underscore, and then this is actually not interspersion tuple, this is sequence tuple. Then we still need to do all this crap. Actually, you know what? We want to return intersperse, and then we want to map that. With this mapper here. Yeah. This takes interspersion, yes. However, the space parser, yeah, that's the space parser. Okay, so now, yeah, we're generalizing. So this is way better, I think. Because so now we know both what the sequence should be and what the intersperse is going to be. Okay, so then we have that. Yes, and this result is t, which we don't have. T is equal to sequence tuple of type parsers. There we go. And yeah, we still do this. So we map over the intersperse now instead. Okay, cool. So now here, instead of doing all this crap, what we do is we simply call intersperse underscore and we don't even need this. Okay, there we go. And now we can use, you know, if you want, I mean, a common use would be to have like parameters. You want to intersperse commas. I don't know, definitions of a struct. You want to intersperse maybe commas or semicolons or whatever. So now we have a nice way of doing that. I mean, maybe you don't want to intersperse actually on statements like that. You want to have maybe, but basically like parameters in a function call, arguments in a function call, parameters in a function definition, and so on and so forth. So basically a lot of things need this anyway, so it's good to have. But now we can use sequence s instead of sequence when we, so let's go back here now. Hopefully it works. So instead of doing these hard-coded spaces here, we'll remove those and we'll use sequence s to now skip that. So now basically all binary, since we have generalized this as well, all binary expressions will support these spaces being you know, any number of spaces, but at least one space, and they can be any type of space as well. Anything that is white space from standard library ASCII module will accept or as a space. Okay, so now we can go back here, and there was some error somewhere. Expected 4 arguments, found 2. Oh, condition. Oh, I see. Expected white space. Actual format is, so the format of this one is a C. So take 1. And this must be comp time. Yeah, so this is comp time. I'm gonna do const tuple equals you know what? But this is just intersperse. So actually we already have this function here. So we actually, we don't need to do all this crap. We can just do tuple equals intersperse tuple type of parsers type of space parser. Do we use it anywhere else? No, we don't. So let's just do this. There we go. Field name should be comp time. Actually, if it's comp time, we can just use comp time print. Which doesn't require a buffer and cannot fail. Yeah, why am I not doing that? There we go. Expected. Okay, here we go. Here's an actual error. Let's see. Root parser function. Oh. Oh. Right. Man, I wish I had like a map tuple type function now. Damn it. Okay. Well, okay, let's bring this back. And this, let's rename this like intersperse. No, this is tuple. Actually, this is tuple field types. And this is type of parsers. And we get that. Should be fine. Space parser. Okay. Are we done here? Yeah, no, this is a tuple. There we go. Thought I was, yeah, and then we need to create this tuple type. This is gonna be meta tuple of tuple fields x. All right. So we still have a bunch of errors. U must be comp time. Yes. We'll make U comp time. U must be like inline. That's still wrong. Oh no. This is actually just field type. And this one is not get parser element, it's actually just space parser. There we go. I'm referencing the fields so much here, I probably should make it like its own thing. So parser fields. I will do this. And I will do that. Okay, where are we now? We are in intersperse, I think, underscore, yes. So values of type struct must become in index values runtime now. What? Ah, let's do, okay, so inline, fine. And this is not comp time. Okay, same thing here, we don't need a buffer. We can simply say comp time print instead. And do this. There we go. Now we only have this. Expected type, root parser function. You're expecting a string and found. Oh, const. Okay. How the. I mean, really, this should really return a const always. We're not supposed to change the results. So yeah, and yeah, take while. This should also be const here. This might mess up a whole bunch of stuff, but which it does. Only 2 more errors. Hang on. Condition. Okay, let's see where this error is happening. Oh, that's something. No, that's not something else. 30. What? No. Oh. Over here. Let's see. Okay. You want to return. Okay, we'll do this. It's always going to be const. Okay, now we can look at the stack trace, I think. Make parser, parse number. Oh, okay. You take while. So is string float. Okay, there we go. You can now be a where is this happening at? Parser 79, string to identifier. Oh, but you're the correct thing. Take at least. That should be correct. Maybe there's something wrong further down the line here. Here we go. There we go. All right. Okay, now it works. So this succeeds. Okay. Now this will still be an error. But if I do this, this won't be an error now. So this still works. Or this, yeah, now this works, I mean. And we can see that if I run this, it will format here. However, actually, these should actually allow white space. Like this should actually allow no white space. So actually what we could do, yeah, what we could do is we could go to the parser and then make binary. We could make this, we could say that this receives an N, which is like, does this require a, so actually, yeah, require white space. Do you require white space in between? Or, yeah, require. And then if, so N is gonna be if require white space 1 else 0. Now here we want to say we don't require a white space. And if we go back now, this should actually compile. And if we update this, we can see that it's still compiled. So now we can have any type of white space we want here. Okay, cool. Now let's just do the same for, you know, the semicolon and the assignment here. Also, there should be, we should skip this part, like, yeah. Okay, a couple of things. I think after the semicolon, if we skip the white space, we will end up at the next token. So we don't really need to check before the X. But as long as we do after the semicolon, we could do also in the beginning, we just skip the first white space as well. So let's do that, because then we'll have like full, you know, no weird white space behavior basically. Okay, so where is our main parser? So basically here we will say skip white space 0, but now we can't use the first anymore. So actually we I want to generalize this actually to be like select, and then from this tuple we want to have a selector, and then there's gonna be like a selector here. Now this selector could be, depending on the parser you pass in, this is gonna depend on kind of the type that you have, but I guess we will just assume that it's gonna be correct. So let's just do an enum here, or actually a union enum. So this is gonna be like first, I'll do like first and second, and then I also add item, which is a U size. Oops, we don't need these. Actually, there we go. So you can either choose the first one or the second one, or you can say, well, it's gonna be this one. We can also add like last, next to last. So basically I have a lot of different options selecting from a tuple basically. And then this is gonna be like selector on, and then we will actually, this could be like home time, so we'll pass this selector in to there, and then this could actually be or F, so we can add a formatting function also to the selector. Actually this is just a tag name actually. Now let's add a formatter function. Okay, and then the selector, here's where we actually do this. So we're gonna switch on selector. If it's the first, we will return input 0. And we can basically map this to a number, but whatever. Second, then it's 1 item, we get the n, and then this will actually be like field input, and then comp time print, and this will be n, and then we have next to last, and this is basically going to be the same thing because we need to calculate. So this would be like well, this would be like fields type of input dot length and -2, and then the last would be -1. There we go. Okay, and we need selector. Actually, let's make this function here instead. So this is going to be comp time selector, and this is going to be the parser, and then this returns a type. So we'll get the elements from parser. Oops. then we will do something. So we get the element from parser. Then we will say yeah, then we do the same thing here with switch. Let's do this. Let's make a function called get item and so index or get index, and then this would be self selector, and we also need the type of the parser. So let's get that, and this would return a usize. So we will switch on self, and if we're the first, we will return 0, second return 1, item n return n, next to last we will return get parser element of parser dot so this is now a tuple, so we get the fields dot length -2, and then last is -1. But because now we can reuse this to get here, we can get the index. It's gonna be selector get index of this parser. We don't get, yes, we get the index and we have the element type, and then we just return field fields of element type and then index of type. Yeah. So we get this is the tuple result. We get the fields of the tuple. We return the index that the selector wants from the tuple and return the type of that tuple element. Okay. And we can also, yeah, this is comp time. So couldn't we also say like selector on instead? Yeah. Okay. And now we need a format. One. Okay, so the format, that's just going to be the number, I think. No, actually, no. This is going to be like switch on self. If we're first, we will try writer write all first. Second item, this is where we need to do print item, and I will just do this here. Next to last. Right. So that's the format function. There we go. Now here we can actually just get the index now. Index of selector, get index. And then, yeah, actually we need to pass in this. And then we can return field, input, content print, the index. There we go. All right, so now we have a generic like select, and now first can actually say, instead of first here, we're gonna do like selector on and then first to get that. Yeah, and this will be the same. I mean, we can still do like a first. I guess we could also have like a first, you know, alias that does this. Technically, we still have this, and then instead of doing all this, or well, it's not that big of a deal actually, but now that we have the functionality, this is just on first parser. And we can even have like second and so on, but whatever. And we don't really need to add a label. Actually, we don't need to do anything here. We just need to return. We don't even need this. We can just return select first. I'm almost tempted to make like a current version, because there you can just say pub const first equals select first, instead of wrapping everything in a function. But then you lose, I think you lose like a little bit if you do that, like LSP stuff. Okay. Yeah, this, so this is comp time, so this index should be comp time. Everything in here is comp time, so I'll just, if I mark this comp time, will it work now? Yes. That's so weird to me, like, if this is comp time anyway, like this is comp time, so this should also be comp time. Like this, it can't be runtime. I mean, I guess it can be runtime as well, but it can't, like, why it has to be, if you set a const to something that is purely comp time known, why isn't this also set to comp time automatically? Okay. Now what's this here? Oh yeah. So now it's like saying, hey, we got the wrong thing, and it's because we're saying first here is firsting a skips white space, but we want the statement, so we do select second now. So now we select the second of this tuple to get the correct type out. So now we support having white space at the start. So yes, very cool. White space at the start. Awesome. Let's just have it there just for fun. We don't have comments, so I'm just gonna keep that. Comments are actually, I mean, I guess it's not that hard, at least for line type comments. Actually, should we just implement comments? Like slash, it's so easy. But let's finish the white space first here. So we have white space at the beginning. So now we want to add white space in the assignment. This is technically kind of like a binary operator, except it's like a yeah, it's a different kind of binary operator. Hello, Steel Toad. Thank you for narrating everything you're doing. You're welcome. I'm a Golang developer looking to get into Zig as well. It's a big help watching this in a practical problem. Okay, cool. Yeah, I'm glad it could be of help. I'm using a lot of comp time stuff in this, so it might not be your usual. Also, it's like very much functional concepts that I'm using here, so it's not the usual, I guess, SIG stuff, but you know, a lot of the thing. I mean, comp time is comp time, so it's always, you know, that's SIG based, of course. But yeah, I mean, I guess I am using a lot of SIG. I mean, I am using the SIG language to build like a functional thing. But yeah, I mean, the syntax and everything, and I mean, everything is SIG, so I guess that's not bad. But I guess just the pattern itself of combining these things here is kind of not, I guess, well, I mean, yeah, whatever. I'm just rambling at this point. Anyway, a lot of SIG is basically learning the syntax, and the comp time stuff is just like, yeah, that's kind of like unique. So that you just have to get into and learn if you want to do stuff with it. All right, yeah, have a good one. See ya. Thanks for stopping by. Okay, so let's see. Okay, we wanted to, yeah, the assignment statement. So this is mapping this contraption to this, and what we want to do is, yeah, here we go. So yeah, this is the same thing. So let's just use sequence S now instead, and this one could be just a character to make it simpler. Actually, the binary expression, yeah, this should really be like a character. Well, I mean, okay, technically this binary operation could be like, could have some more characters, I guess. Okay, whatever. Where's the assignment? There. So yes, yeah, okay, so now the assignment operator should have support for oh yeah, require white space is false. There we go. So now we can do things like this, or things like this if we want. Oops. Wait, is it? What's happening? It's failing? Oh man. Type miss. Oh, it's a type error. Mapper function. Oh, hang on. Yes, so where, so okay. Where do we get the error at? We have parser 104 here. So did the type change? Oh, because it's a character now, okay. Right, so this is just a U8 now. There we go. I mean, technically, actually, we could we could make this into an any type, so we don't have to specify the type. Yeah. Anyway, yeah, there we go. Now we got our little program out. Let's go here. Now this succeeds, and we look at our output. Yeah. Now we get the same thing as we had before. Cool. So now we can have white space in this thing and it still works. Great. All right. Now, but we cannot have white space here. This, yeah. Right, it expected white space. That's weird. Okay, anyway. Okay, let's fix this. I think this is like the last thing, and also after the semicolon. Once we fix that, we can have like white space anywhere we want, and it won't be a problem. And then after that, I will just add comments, and that's going to be the last thing that I'll do here because it's late and I need to sleep. But it's fun. It's so much fun to do this. Okay. And the parser system is improving and stuff. So now, let's see. Also, hang on. I haven't seen announcements and stuff. Of course. Wait, what's the fuck? What the hell? Steel Toad gave out community sub gifts. Oh, thank you. I don't know what that means, but that sounds cool. Thank you so much. Hype train just started. Yeah, I should really work on getting like announcements and stuff. Damn, thank you. Thank you so much. I mean, I don't know what that means. I'm so new to this. 1 second here. I mean, shit, is that subscriptions? Thank you. I mean, you're the first. Okay, so this is like historical now because you're the first one. You're the first one to subscribe here. Thank you. Thank you so much. Wow. Cool. Awesome. Yeah. I don't have like you know, the announcements here, but thank you. All right. Where were we here? Oh yeah. So weird you can get the error messages in here. Okay. Let's see. Okay, what we're doing? I totally lost my. my bearings here. No problem. Okay. Yeah. Oh yeah, the white space on white space. Hang on. Yeah, we don't need this anymore. Optional ends. New line here. We don't need you. What we do want is, okay, this is kind of weird. This is kind of like inside out here, that these statements each has responsibility of consuming a semicolon, which could make sense if you have like a different kind of statement, because you can have like an if statement, for example, that doesn't have a semicolon. So it could depend on the type of statement that you have. But usually if you have a statement like that, you could divide it into two types of statement. You can have a block statement that uses perhaps curly braces or brackets or whatever. That could be one type of statement. And then you can also have like, I don't know what to call it, but you know, semicolon statements or whatever. They're probably called something. But these two have like their own responsibility. Otherwise I would put the semicolon out here, because now I have to replicate this behavior. Actually, let's do that. Yeah, because I have this two statement parser. Actually, this works though, maybe. Yeah, this works, because this is like, this is common, so I don't have to replicate. Actually, I could just add it here. I mean, it's gonna be replicated in basically like in the code, or I mean in the generated code, I guess. But since we're calling this from several places, instead of having one parser that adds it, we have several that like handles their own stuff. But yeah, this, if we just add s here, and crucially also here at the end, no wait, no, we add s here. White space is not required between the semicolon and the statement. Then where, yeah, this also uses like two statement parser. But then we have this here, this, but this is a take while. Actually, no way, we can make this into a sequence. Yeah. Okay, we'll make this. Why did it get two indents there? Anyway, sequence, and we'll have statement, and we already skipped the first one. I mean, we could also add these here. Yeah. Which is kind of like a sequence interspersed, two white space interspersed with a statement. This doesn't work though. Actually, we need to map this. We need to take the second, or we need to select the second one now out of this. There we go. So now we're selecting the second. So we're grabbing the statement out because it's the second item here out. So that's gonna be the result of this. Oops. Parser. There we go. Yeah, that's fine. And now we don't need to do this anymore, so we don't need to select second here. Why? Okay. I was like, why do I have a breadcrumb in here? We have like 2 breadcrumbs. No, but this is a label. No, you're that. You, I'll just remove. There we go. What the hell's going on here? Oh yeah, we need... Oh yeah, they want the builder, I guess, I think. Hey, it fits on one line, so there we go. The parser... Wait, expected parser function... On this one? Yeah, expected the parser function, yes. Wait, so what's the issue? Because this is the parser function. And we're returning a tuple with the parser function first. It's saying that it found... Oh, it found a weird result. Okay, yeah, I see it. I see it. This is a tuple now. What? Oh, wait. This needs. No, we need first here. There we go. There we go. Okay. Okay. Are we done with the errors? Maybe. Yeah. Hang on. Let's open out and we run this. There we go. Now we can have whatever white space here, and there's no issue. And let's just check at the end here as well. There we go. So now we don't have to worry about any kind of weird white space, you know, errors. Whoops. Okay, cool. Okay, so the last thing is I'm going to add comments. So let's just see what it complains about here. Yeah, expected white space, actual. Why does it go over there? At 1, 2. Okay, that's strange. Anyway. This should be fairly easy. So we'll go to, we don't need to, so the thing about comments, you don't need to store them in the AST. If you don't want to, of course, you can have things like annotation, like, you know, type annotations and stuff. But for the purposes of this here, we don't need to store it in the AST. So we don't even need to create any AST nodes from it. But we can, but the parser needs to be extended. So we are going to have probably like, I mean, yeah, this is going to be like a multi-expression. No, it's not going to be expression. It's just going to be a comment thing. I'm just going to add it somewhere here. Comment, and how to parse a comment. So basically you have, I mean, we just start at 2 slashes forward slashes. So basically we could make a sequence. So first we're gonna have parse character. Actually, we have a parse string. Okay. And then we want to parse until end of line. So take while, and then it's basically take one. So we're taking anything. Actually, we need to basically say it's not take while. It's not. So do we have like parse? We have like parse char, but we kind of want the inverse. So parse not char. And add label parse char. Yeah, so this is not char. Whoops. And then the predicate is going to be that it's not equal to char. I'm thinking about some kind of combination, you could, like combinatoric thing you can do with, you have some sort of condition already, but then you just inverse it. But it's hard to see that, okay, we actually have a condition. I mean, I guess we could sort of see it, but it could also be wrapped with other stuff. So it's kind of hard to actually inverse. It has to be maybe, if you have a condition parser at the top level, then you could invert it. Technically, it's just wrapping it with a condition, taking the predicate out of the existing condition. Maybe do we actually have that? Well, I mean, we have the closure, and the closure. No, the predicate function is actually not part of this, so there's no way of knowing. Oh, that's interesting. We have to store the predicate function somewhere in that case, I think. Okay. Anyway, never mind. I was about to say my language equivalent of never mind. Okay, so condition predicate to see not equal to, yeah, everything else should be the same, I think. Okay, so now we can actually do like parse not char. So while it is not end line, new line, we do that, and then you also, no, that's all you want. Okay, cool. Yeah, so now we have a parser for comment, and we basically don't really care about the contents. It's just gonna get ignored. So actually this kind of changes this one a little bit, and maybe we can actually make this nullable. Or This is interesting. Can we somehow make it... I mean, we can't... It can't reference itself, I don't think. Like, if you try to... Let's say we have a sequence of a comment and then a statement, right? That doesn't work. Oops. Because that would be a recursive yeah, that's like a what would the type be? That would be like an infinite loop here. But maybe we can add, actually here we can say one off. No, but then we're back to the same problem actually, because one off needs the same type. We could make a sequence. We could surround it by optional comments. Interspersed with skip white space. This looks ridiculous. I'm not sure. Maybe this will work. Okay, so now we can say item 0, 1, 2, 3. Hey, it works. Yeah. Maybe we can even put... I mean, technically, we could also take the comment and put it where it is. But, yeah. I'm just gonna add this in different places here. See if it works. Okay, okay. We need to be able to handle more than one comment. Okay. So this could be like, I guess, take while. And sequence. So we're taking while we have like comments. So we're skipping all the comments. Oh. Okay, so now we have this issue here. So this is the second. Yeah. What do you let's see. Okay. Now let's go back here. Okay, we get no errors. But it's still running. Okay, so there's the infinite loop, probably. Maybe because everything is optional here. That's the issue. Like, it skips this one, there's no comment. And Yeah, so if you're on an empty line, but we should get to the comment. No, but if you're on an empty line, no, you should get to the next comment. But okay, so but if we're not on a comment, I see. If we're not on a comment, that means that okay, we can have 0 white space, so that's skipped. Optional comment, that also returns, that also like doesn't fail. This doesn't fail, so none of these fails, and you're stuck in an infinite loop. Because if there were a comment, then this would succeed and consume the comment. This would skip to the next token, and then we start all over again. So this one doesn't do anything. Now, if it's not a comment, this will, since it's an optional, it will succeed. So I think I will remove the optional part. There has to be a comment, because this take while will actually not like report an error if there wasn't a comment. It will just say that okay, there wasn't a comment, so now we quit. I think should be good. Okay, there we go. Now it works. And let's. Oh, it changed something? What happened? Why does it say like 5 minus 2 here? That's weird. Okay, maybe there was like a bug in the thing before. Okay, but now we have comments. Cool. And we can place them basically anywhere as far as I can tell. One thing that I haven't tested is having a comment here. Comment at end of line. That doesn't work. Okay. But why? What? Expected white space? Wait, what if we remove? There's an error here. All right. First we skip the white space, nothing happens. We skip the comment. We should be like at the end line now, the new line. We skip white space, so we should be over here. The assignment statement is read in. Now it's saying there. What happens if we remove the comment? Do we still have the same issue? Yes. So we read the statement, which should be this. This shouldn't do anything to the code here. Is there something weird with that assignment statement? So identifier. Expression. Statement parser adds. Skip white space in between, and then also this. Okay, it's time to bring out the trace. Where is the builder? Tracing. Right. So we will do this. And there's some sort of error somewhere, but we don't see it because we don't get the whole thing. There we go. Couldn't parse source. Okay, what are you doing here? Okay, so we are at the first. Let's look at this. So basically, man, we're at the 1.8 for a long time. Holy crap. And this should just, yeah. I think it's trying to read maybe an expression here. Oh, this is the assignment statement, yes. And then it. Okay, so now we're reading parse character, yes. Take one. It succeeded, yes. All right. And this one succeeded. Assignment number, assignment identify X value literal number 15. And then we are running, yeah, this succeeded, okay, yes. Yeah, so we're basically exceeding out of this thing. Right, yeah, that was the statement. So the statement succeeded, yes. Now we're running some parser here. Statements parser. So, okay, so we should. Actually, okay, let's annotate some of this. Comments should definitely be annotated. Comments. Then I think these blocks what to call that, like comment around comment, I don't know what to call this. And I'll breadcrumb that as well. And we'll just take this block here, put it in there. So now we can have those there. Okay. Okay, let's try this again. If we can, there we go. Man, there's so much until we get to like 1.7. Now we're at the end here. We're reading around comment. Take one succeeded, condition succeeded. Okay, so now we're here. We're still at around comments, which is probably why what the issue is, maybe. Or wait, restoring. Oh, I see. So it succeeded with that. So that was the skip white space, I think. And now we're running something else here. Okay, actually, let's set the label here. But let's continue here anyway. So take at least 0, 16. Now we're running something else that I can't really see. Sequence. Okay, 2 strings. Yeah, I think that's... Is that... Whoops. Is that the comment? Yeah. So string 1, string 2 is this one. Okay. Okay, and here you can see, yeah, parse string, that should fail. Why doesn't it say that it fails? Oh, it's parsing the character. Right, so we're parsing a sequence, right. This is a sequence of these characters, but that should fail immediately. This succeeded, but then we failed, so we restore. And it stopped. And then this succeeded. So now we have the state. No, wait. What the hell is this? Assignment. Didn't we already have that? Or am I tripping, as they say? Yeah, here we succeeded with this, but maybe that was another part of it. It's hard to keep track on this thing here. But okay, let's say this is correct. We succeeded with... Okay, maybe there was like another one. And then we select the second to get the statement. Okay. Why did we roll back though? I mean, it doesn't matter because we should... That's still reading like a round comment here. Okay, so where is it actually like getting here? It just goes to show that there's a lot of things going on when just adding the thing with the around comment thing. Like there's a lot of processing there. Okay, so all of a sudden it's at 2.2. Is this just an error in... It might be just an error in the logging here. Like it couldn't read it fast enough, maybe. I don't know. I don't know. There might be like repetitions and stuff. I don't know, man. I mean, let's just do this. No, it just seems to jump straight to there. What the hell? How does it get over there? Oh, I see. This kind of shows the... Okay, so this shows the wrong thing, actually. The error shows like one column off. I see. Why is that? Is it because when the error happens, it's like taking the index after the after it has been consumed? expected white space. Yeah, so the condition the condition takes a predicate and a parser, and if the predicate, and it runs the parser inside the monad here, and if it fails, well, if the inner parser fail, we just return that. If it succeeds, we get the value, we run the predicate function on the value. If it's true, we report success, otherwise we report an error. But at this point we have already consumed the whatever this parser was gonna do. So I think if we create a snapshot here, and then here we actually do restore the snapshot. Now that should work better, I think. There we go. Wait. Okay, now we get the now I think we get like the correct place. But this is okay, so this does succeed, and then it's like expecting a white space. That's weird. Like, where are we in the thing? Like, just says the parser, which is the main parser. This is the actual, like, this is the outermost place where we can be. And then we have the statements. Expected white space. That's so weird. Where do we expect a white space? I don't think we ever expect a white space. Oh, it might be because it's the furthest error, actually. So that is kind of weird, like that error message. Because, okay, so how the error messages work is basically I'll try to find the deepest error that ever happened. Like the error that happened furthest is, so that's the heuristic that I have right now. The error that happened, we can look at that. Yeah. So we get all the errors. This is basically all errors that ever happened. And we look for the one that has the gotten the furthest into the source, and then we show that. And now this happened to be like some weird, like because this probably fails, or this one. And then there's nothing, when there's nothing else to check, it fails the entire thing. I still don't understand why it's failing, to be honest. Because this is a take while. Take while will exit even though there could be no items matching. So it's like a star wildcard. It can match 0 or more items. So even though we have like these here, they don't have to succeed. and then we have a statement, and then this one is also repeated, and so I don't really understand what's happening. But that's gonna be it for this time. Been here now. I need to sleep, and yeah, but thank you very much for watching. Thank you so much to Steel Toad for the subs there. That's incredible. Yeah, so yeah, that's gonna be it for this time. So hope to see you next time. See ya.